Yeah, I'm Jessica Kerr, Jessitron online, and I work at honeycomb.io, which will be relevant shortly. My background is in back-end development. For the first 10 years of my career, this was the universal architecture. Box, arrow, cylinder. Front end, back end, database. That was it. This was every architecture diagram everywhere. And things were simpler. But, in the last 10 years or so, everything's gotten more interesting. And now we have microservices. We're stuck with them. And we've got multiple databases of different types. And we've got, now our apps are calling out to OpenAI and getting non-deterministic results back. And everything's more complicated in the back end. And meanwhile, all the customer-facing difficult work has moved into the React monolith, and the client's gotten bigger, but it's still just one typically, or there might be multiple ones, but one at a time. And things have gotten more complicated. When it was just box, arrow, cylinder, it was enough that we had infrastructure dashboards that the infrastructure and the database people watched. And we had APM for our web services. And then we searched logs for anything to find out what was happening when there was an error. And then in the front end, we've got things like RUM for real user monitoring, and we've got error tracking. And these things are generally separate. That's not good enough anymore in the new world where things are cloud native and there's lots of them running and you don't know how many of them are running. We need something better. Today I'm here to talk mostly about OpenTelemetry. And OpenTelemetry is part of the Cloud Native Compute Foundation. It is the second biggest project in the CNCF. Does anybody know what the biggest one is? Kubernetes. Right. So this is a very open source, very well-governed project. Now, project is kind of a small word. OpenTelemetry is many things. I'll talk about some of them. But the objective of OpenTelemetry is to give us the observability we need, the ability to see inside this wider system from front to back in one format, so you can put the data in one place and everybody can talk about the same thing instead of a bunch of different systems. And what I need out of this system, I needed to tell me how it fits together. So I need an observability platform, whatever. I need observability that ties the whole system together and gives me the causality of, this database failed. One, I can find out where the error happened. It was down in this database. Why? What was the input? What led to that? What led to that? What did the user push? That's what I want. And I want it to scale in multiple ways. Brian talked about multiple ways of scaling earlier. One is volume, that would be scale in number of users. And one is complexity, that would be number of features. Also, number of instances of services running. Metrics scale amazingly with volume. You can make those numbers bigger and until you hit max int and they're big ints. You don't need any more space. Metrics do not scale with complexity. Once you're trying to say which server is down, and this is a Lambda, and the server is different every time it runs, that doesn't scale with metrics. Logs scale, linearly with volume, and they handle complexity okay until you get concurrency. Logs work great on my local system and terrible in production where there's a bunch of things happening at the same time. So we need tools that scale. And finally, the last bit is about everybody who supports this whole system being able to talk and use the same query engine, the same screens, and talk about the same thing. So we need stuff very flexible. And OpenTelemetry is about standard protocols that are also vendor neutral. So that you can choose your tooling or even send to multiple toolings, but base it on the same data. Okay, now some definitions. Talking about observability, so I should define that. Observability is you know how your system works because it tells you. So it is a property of your software and also all your whole tool chain. How well is it telling you what's going on inside of it? Because if we want to scale in number of developers, this is the best thing. You can draw that whiteboard diagram all you want, and if it fits on a whiteboard, fabulous. But what's better is getting the software to draw it for you, because that's reality. Your architecture diagrams are always out of date. Where does observability come from? The word comes from rocketry and like rocket science, because when you shoot off like a rocket or a missile or something, and then you hear in the news, oh, and it went 500 miles an hour by 10,000 feet. Did we have like a cop with a radar gun in a plane at 10,000 feet? No, we didn't. How do we know it's going that fast? Because the rocket told us. And it tells us with telemetry. Telemetry means the data that the system emits just for us, just for its developers and operators to know what's going on. And we have this in our systems. It comes from code, and that code is called instrumentation. So instrumentation is code that emits telemetry that's just for us. The rockets have it, we have it. It might be as simple as a console.log. That's not very good telemetry, but it is telemetry, and it does give you more information than technically zero. At least I can know I was here. But there's one more piece in software observability. We're not just firing one rocket in the air. We've got a whole bunch of services going on at the same time, and they're all talking to each other. And we need to know about that talking to each other. And the chain of causality crosses services. So we add propagation. Propagation is when you stick enough tracing information inside the message. So when one service makes an HTTP call to another, in the HTTP header, there's it's called trace parent. There's just enough information to say, what is this part of? Where did this request come from? And we can tie them together. OpenTelemetry helps with all of these steps. It's got protocols for telemetry, it's got libraries for instrumentation, and it's got libraries, and actually it's a W3C standard to what header to put in your HTTP requests. So all of these pieces that make it possible to build observability. The propagation lets us build service maps. This is our generated architecture diagram. Now this is the generated architecture diagram of an e-commerce app. It's a pretend e-commerce app. It's called the OpenTelemetry demo because, among many other things, OpenTelemetry maintains a demo project, which is a gratuitously complicated microservices app with microservices in 10 different languages that does nothing in this very fancy way. It's got some of these are in Golang, some of them are in Node, some of them are in .NET, there's Java, there's Python. The purpose is to demonstrate distributed tracing and the data that we can get by tracing requests through these services. So you'll see some of that. I'm going to show it to you. And as I talk about what OpenTelemetry does in the back end. So in this talk, I'm showing you this back end stuff because I wanted to be like, how do we get this in the front end? What do we have in the front end and how does it compare? And how do we combine them? So here's the OpenTelemetry demo project. And you can go here on your phones or whatever. You can, if you do jesitron.com/otel, it will redirect you to a slightly larger URL. But this is where I'm running the OpenTelemetry demo in EKS. And I'll go click on it. But you can click on it too, and it'll help because then there'll be more telemetry data from all of our interactions. So if I do jesitron.com/otel, it goes here. And this is the fake e-commerce astronomy shop. And you can click on stuff, and you can put it in your cart. And then you can scroll down in your cart, and it's got fake data in here so that you can just real quick click place order. And that does a checkout, and it says, we've sent you a confirmation email. It's lying. It has not sent you an email. It does nothing. But what it has done is created some tracing. So if I do jesitron.com/otel/Jaeger, Jaeger is also part of the CNCF. It is an open source tracing storage and display product. So we can see what a distributed trace looks like in Jaeger. Probably this is the demo version of Jaeger, and I'm not using a real database, so whenever it runs out of memory, it just falls over and starts again. Thanks, Kubernetes. Okay, but here's, I've clicked front-end web service. That's the browser's name, the browser client. And I don't know, here's a big dot. This is probably a checkout. Okay, is it a checkout? Nope, it is not, because it is going to product catalog service. Search again. Where's my nice fat checkout? Oh, here, that's probably one. Nope, that's document load. We'll talk about that in a minute. I know, I'll go to checkout service. Checkout service, you got any traces? Yeah, look at that nice fat one. Okay, here's a checkout. Great. So yes, that's how you find traces in Jaeger. It's not the only way. But now we have a distributed trace. Okay, what is a distributed trace? Why do I care about it? Why is it so good? A distributed trace describes the processing of a request really well. So the request came in this case, we're starting at front-end web. It went through the front-end proxy. It went to the front-end service, which is called front-end because it's the beginning of the back-end. And then there's the checkout service, and it went to the cart service, and it went to the product catalog service. And over here, it's a little hard to see because of, the difference between the client and the server is clock skew. The clock skew is making this a little difficult. I don't know how to make Jaeger zoom in. But over here in this waterfall view, you can see, while the front end thinks it took 177 milliseconds, on the back end, by the time it got to us, it took 78. And a lot of that, 52 of those were in checkout service, but then checkout service did all these other steps. You can trace the transaction through the different services. It's like a stack trace, except cross-process. Yeah, I remember the first time I switched from C to Java and I saw a stack trace and it was like, oh my God, I could actually figure out what happened. Distributed traces are that for microservices. And to do that, there's a bunch of data being emitted by all of these different services. Each of these is sending out telemetry data that gets constructed into this one big, gigantic trace that describes everything that happened. So when there's an error, you can go right to it. Also, you can add details. So let's see, if I pick one of these, you get like some generic attributes on all of these. So here's like, where's it running in Kubernetes? They all have that. And then you can also customize them. So these app.attributes, order amount, order ID, shipping tracking ID, these are added with a line of code here and there that's custom to the OTel application. So each attribute on here, plus the beginning, plus the end, plus the status, replaces a log line. So each span in this trace, it's called a span, the like amount of time that you did some particular unit of work. But each span row in here contains multiple log statements worth of data. You can also have logs and stick them in here and they show up somewhere, but down at the bottom, I think. Right, so that's a distributed trace. It's pretty cool. You can see what took so long. You can see concurrency. Go back to the slides. You're gonna have to click through because it actually, oh no, where's my, we were here on this OTel demo. And we saw this and we saw a trace. This one looks a little nicer. This is my, my in case the internet doesn't work slide. We saw some specific fields and some customized fields. And the causality of why did things happen is expressed in this tree structure that builds up. So checkout service caused payment service to do something. And then you put all that together and you get your cool architecture diagram that can show where all the different connections are. You can also see what happened like one after the other. You can see what waited here, and you can see that these didn't wait. They all ran at the same time. This is the best way to debug node concurrency errors, man. I have looked at these things and been like, oh no, that shouldn't have happened yet. That should wait. Very useful. And we can explain what is slow, which is really useful because you can see exactly which of these bars is the longest. And that's super useful. So when you need to work on performance, this gets you to the right place. It's not profiling at this stage. It's just like this request, this service took so long. And you can count over all of production how many times was that service called, and so you know what's important to work on. And in this way, we think about the user experience. So our objective as observability is like people having clues about what's going on in the system. And to do that, we look at screens. Those screens are running queries on a database somewhere. Don't worry about that yet. And that database is populated with telemetry data that comes from our software. That software contains instrumentation, and this can be libraries or code you write. Usually you want both. You supplement with like your user ID, your pricing plan and stuff to spans that are created by libraries. And then also you send it through some processing. This is normal. There's a data pipeline before it. And OpenTelemetry shows up in all these places. Instrumentation libraries in all the languages and for all the different frameworks. The OpenTelemetry collector, which does conversions and sends everything out, well, I always have it send everything out as OTLP, which stands for OpenTelemetry Protocol. That's the standardized protocol, and that is accepted by many different backends. It also, the collector in the pipeline here will translate from Prometheus, from OpenCensus and OpenTracing and all the older standards. So there's a lot of compatibility stuff in OpenTelemetry. Yeah, the collector accepts all these different formats, and also it can send out to multiple places. So my OpenTelemetry demo is sending both to Jaeger, the open source tracing tool that's running in Kubernetes, and to Honeycomb, which is where I work. Honeycomb is an OpenTelemetry front end. We accept OpenTelemetry data, we store it in our custom database, and then we let you run cool queries and make cool pictures with it. So you can send it to both. It's vendor neutral, and this is crucial. When you are working on observability in the back end, everyone these days is like, step 1, go to OpenTelemetry. Step 2, let the CIO on the golf course choose the vendor. Hopefully better than that. But worst case, you're prepared as long as you're making OpenTelemetry and you don't have to run somebody's custom proprietary agents in your software. Okay, so that's OpenTelemetry. And it's really great for the back end. It does tie that whole system together. Those distributed traces of a web request, as soon as that web request is being traced, we've got all this. And you can tell, we put like CPU and memory utilization and all those metricy things right on the spans. And so you can tell resource contention, and you can talk to the database people. You can, at least in Honeycomb, you can graph over those trace spans and logs. OpenTelemetry also has metrics, protocols, and things like that. So you can get all of this for the back end. But what about in the front end? In the front end, we're working on it. OpenTelemetry is working on it. Honeycomb is contributing to that. And I personally have some entertaining play. Because when we talk about, at Honeycomb, we do this, we talk about the user experience as status code and latency. Because we model the user experience at that back-end entry point at are our services responding with success fast enough? And yes, it's important to care about that, and it's important to have this data and know when you need to improve performance, but that's not everything. Okay, let's talk about what we have in the client. Currently, we have Google Analytics. We use this in Honeycomb. We also use, well, we do RUM in Honeycomb now, but there's RUM solutions. There's Amplitude for user flows through the product. We use that. In a pinch, there's Full Story, which is the creepy spy thing that records the entire session, including everywhere they clicked. Sometimes we use that. That does not scale. We also use Sentry for error tracking. There's a lot of these different tools, and we want to get back to OpenTelemetry. But there's another tool that we use more than any of these at Honeycomb, which is our own telemetry. Now this predates OTel, but we could be sending OTel, but actually it's older than that. We just send events. And our model of observability the kind of observability that I want to get to, Observability 2.0, where everybody's looking at the same data, is based on wide events. Those could be trace spans, those could be structured logs. But one way or another, our front end is sending home reports of a bunch of things that the user did or that the system did. The requests are like back-end requests. And we use these more than anything else. We don't have like this complicated tree structure of causality, sadly. It's just they were on this page, they did this thing. It's better than a lot of things. And we've got those custom fields. We can add all that detail. And then we can aggregate over them. So which customers are using this particular feature? Mostly enterprise customers, but also a lot of self-serve paying customers. And then the free. We have a lot of free customers. Right. But what does OTel have in the browser so far? So far, we do have some things. We have some automatic instrumentation for sending to the backend for document load and user interactions. And it's a little bit of code to set this up, but it's just a little. Well, and a couple megs of libraries. The fetch and Ajax instrumentation add spans and establish a trace ID and send it to the backend so that we can connect it. We saw that. And that adds this tiny little front-end web box to this architecture diagram, as if there's not 1,000 zillion things happening in there. It's a start. With a little bit of code, we can add session ID to every one of those spans. And that gets us, in theory, in Jaeger, we could search by that. I haven't got that to work, but yeah, demo version of Jaeger. I'm sure someone's gotten that to work. And then we also add some, this is just a bunch, or in Honeycomb, I can construct a SAD timeline view. We're working on this, more on that if you talk to me at the booth. And then we also have our events, which are my favorite. Right, document load. Yeah, I actually use our events more than the OTLP stuff right now, but we're getting there. Document load is some automatic instrumentation. This is easy and useful. You can see what took longest to load. Everybody needs that. And in this case, you can see like that one. Let me add, in Honeycomb, this is the same trace, but I've added the, what the heck was it trying to load? So you can see what took the longest. It's this banner. That's probably because it was like 35K. That's useful. But personally, as a developer, I mean, yes, somebody needs to work on performance and make the page load fast. I'm worried about all those different components in my giant React monolith and how they interact. That's what I want to see personally. Core Web Vitals, that's another thing. There's a line of code to add this. I imported it from our open source wrapper for the OTel libraries. And finally, user interaction. Now, this is what I want. What I want is to tell it, okay, tell me when they click submit, when they click a button, or when it doesn't actually do the key press thing, as far as I can tell. But now I want that button click to like connect to what happened in the back end. That's what I'm after. Unfortunately, this is what I get. Yep, they clicked it. It took microseconds, nanoseconds, because all it was a click. And what did they click on? HTML, body, div, header, nav, div. No, this is not helpful. So the user interaction instrumentation is pretty don't bother. Especially, I have seen it do something useful, but not in React. So yeah, is this observability? I don't think so. It is not giving me causality, and I'm sad. So what I did get to work was, no, this is what I actually want. What I want is you click add to cart, you get a nice trace that says, I clicked cart. Oh, we posted. Oh, we did a get after we posted, and then we navigated to a different page. That's what I want. But this is what I get. A bunch of broken up indications. But there is a zone context manager, thank you Angular for this library, wherein we can try to trace execution across promises and callbacks and stuff in Node. So you add this in the configuration a little bit. And then I hard coded some, and it helps a little. It helps with promises, it helps with callbacks, but React, oh my gosh, has its own abstractions and stuff. One time I did get this to work. I did get a click, and then a post, and then a get, and then a navigate. And it's good that I took a screenshot of it. Because then someone went in and upgraded the OTel demo front end to use React Query. And yeah, now what I did get is, I'm not going to go click on it for time, but if I click on empty cart, I can say, aha, empty cart button, and I can get as far as that HTTP delete. I had to add some code for this a little bit, but I did get that to tie in, but I can't figure out how that ties in. I'm pretty sure there's a get after that. I'm pretty sure there's some navigation, but I can't make it work yet. So that's what I want, is that kind of causality. So in Honeycomb this year, we have like a project. First, RUM, that's easy. That's some graphs on top of the data that we can already get from OpenTelemetry. And then what we're aiming for is front-end observability. And one thing I would love to hear from you all is, what would that mean to you? What kind of information would tell you when you're coming to a new front-end, okay, let's start with a React browser app, to a new one that you're not familiar with? How do you figure it out? And what do you wish you had? Because we can do RUM, that's fine, that's easy. And then there's Observaquiz. So this is my personal attempt at making a trace that's meaningful to me. And actually, if you go, if you do the Observaquiz, which is at quiz.onlyspans.com, and you can do the thing, and this will be harder for you, but that's, and then it asks you some nice questions. What is it? It asks you some questions. I'm going to put some nonsense in there. And then it talks to ChatGPT so you can get silly answers. The interesting part is that I've done some really weird things with the tracing on that one. Oh, my hello screen was up for a long time. Bummer, because I had it up in the background. But there's the different components and stuff, and then there's events pointing between them. I would love to talk more about it at, this is why I got a booth, so I could talk to y'all about this stuff. And if you do the Observaquiz and you complete it, I'll give you a Lego unicorn. It's pretty cool. But really, I want to know what you think about this tracing. It's lost my place. We did that. And this is where you're going to tell me about that, or other people about that. So OpenTelemetry has community. You can join the client instrumentation special interest group and the end user working group. You can also get updates at hotelinpractice.net. I publish a newsletter there. Because we're not going back to this. Simplicity doesn't solve our problem, because our problems aren't simple. We have this complexity for a reason. Now, some of it's gratuitous, and definitely avoid that. But in the end, we're solving more and more interesting problems for our customers. All of the complexity of a particular task, be it sentiment analysis or healthcare or asking stupid questions, is abstracted from the user into our software. We want to support complexity. We want to support features. So we're not going back. The only way is forward. And that way is by getting the software to be part of the team and making it tell us what the heck it's doing and where it needs help. And behind every one of these pieces of software, hopefully, otherwise you need corgi bites, is people. There are people in all of these places, and observability speaks to all of them. Great observability, Observability 2.0, speaks to all of them in a way that they can all live in the same world and communicate with each other and change the software usefully. The end.